This is momentum example number 3, and this is the problem where you have Venus Williams, who is illustrated by the picture here, is going to hit a tennis ball, and that tennis ball is right here. What'll happen is the tennis ball starts by moving to the left, and when it's moving to the left, it has a speed of 10 meters per second. The only problem that we have with this problem is we need to make sure that we define an axis. So we're going to say anything to the right is going to be positive, and anything to the left, the speed will be negative. So because we see that this ball is moving to the left, we need to make sure that we have the speed negative since the ball is moving to the left. Once the ball makes contact with the racket, then that ball is shot off in the opposite direction, and that opposite direction gives us a speed of 36 meters per second. It's pretty important that you understand when the ball goes one way, it needs to have a negative speed, and when it goes the other way, a positive, or vice versa. Either one will work. For this problem, then, we can continue by looking at the different speeds. We'll say that the original speed from our diagram is equal to negative 10 meters per second, and our final speed is equal to 36 meters per second, and remember that that 36 is positive. The mass of the ball is equal to 0.06 kilograms, and they want us to find out what is the change in momentum of the tennis ball. Remember, change in momentum is equal to the mass times the change in velocity. So we'll rewrite that equation. Mass times the change in velocity would be the final speed minus the original speed. It's critical that you do this for this problem. For the mass, it's 0.06 kilograms. We said our final speed was 36 meters per second. And we know that our original speed was, so we have minus a negative 10 meters per second. So in the end, our overall change in velocity for that ball was 46 meters per second. We just take the 36 minus negative 10, and that will give us that 46 change. When you do your math, you should end up with 2.8 kilograms times a meter per second. And that was part A of this problem. For part B of the problem, it says if the 0.06 kilogram ball is in contact with the racket for 0.02 seconds, with what average force has Venus hit the ball? This is very similar to the last example problem that we did, example problem 2. This is example problem 3, and this part is part B. Remember from previously, we know our mass is equal to 0.06 kilograms. We also know that the change in speed from the previous part of the problem was 36 meters per second minus negative 10 meters per second. If you go ahead and calculate that, you'll get 46 meters per second because it's 36 minus the negative 10. We'll go back to our equation where we can relate the force times time, which is impulse, is equal to the mass times the change in velocity. Now we can plug all our variables in. Of force, we said that the time from the previous part of the problem was 0.02 seconds. That's equal to the mass, which is 0.06 kilograms, times the change in speed, which we determined was 46 meters per second. We can rewrite the equation to have F on one side, so that'd be 0.06 kilograms times 46 meters per second. We'll divide that by 0.02 seconds. When you go through and figure out how many newtons that is, you'll find out it's 140 newtons, or 140 kilograms times a meter per second squared.